Hello student, I am Arnab Das. Today we discuss a BCH code by explaining an problem, and that one will be the so easy for understanding for the BCH code, and also the way by which you can also generate the generator polynomial for the BCH code. The problem is that define a 15,7 binary BCH code with t is equal to 2. So in the question it is given that n is equal to 15, their k is given as a value of 7, and t is defined as a 2. T is means that how many number of bit error it can be correct. In this BCH code, if at the receiver side 2-bit position any error is occur, that time also it can be able to rectify, and the message bit is 7, that is the k, and code word length is 15, that is n is given on there 15. So here for the BCH code, as we know that n, that is the code word, should be is equal to 2 to the power of m minus of 1. That means m is defined any kind of positive integer number, that one should be as such, the value will be as the same of the n. Due to the reason of this, n is equal to 15 in this case, so here m should be equal to 4, because 2 to the power of m can be write down as equal to of n plus of 1. So from there you can able to identify by using the log value base of 2, you can able to identify what will be the value this one. Otherwise, trial and error process, you can apply the value to get the value of m on there. So lastly, we got that the m is the value of 4 on there. So we have total 4 kind of information. One is the m equal to 4, 2 t equal to 2, 3 n is equal to 15, and 4 k is equal to 7 on there. To generate the generator matrix or polynomial in this BCH code, initially you have to identify the primitive polynomial. To get the primitive polynomial, initially identify what kind of Galois field or primitive element you have to choose on there. Let initially alpha is the primitive element in Galois field 2 to the power of 4. Question is that why this is 2 to the power of 4 or f2 of superscript as a 4? The answer is that there already you got it, the value of m is equal to 4. So for the function or field, the degree will be 4. That is 4 is defined for the m. 2 is defined in the question, it is given to a binary BCH code. So q value should be equal to 2 on there. And for this reason, it is written as such. Again, I just repeat that. Here f as a subscript written as a 2 due to the reason of this is a binary BCH code. For the binary, their mod operation is done by the 2. So this is 2, and superscript is written as a 4 due to the reason of that you already calculate m equal to 4. So degree for the field will be 4, and for this reason this is written f24 or Galois field 2 to the power of 4. Consider the primitive polynomial, this one. Here the 4 is the degree, so should be the primitive polynomial highest degree will be 4. So we just consider this one the primitive polynomial. If the primitive element is alpha, that is define the root, then You just replace the value of x as a alpha. Then this one can be write down as a form of equal to 0. From this, you can write down alpha to the power of 4 equal to alpha plus of 1. Question is that why alpha to the power 4 is equal to alpha plus 1? Why it is not? From this equation it cannot become as such. This will become as such. This is alpha to the power of 4 is equal to minus of alpha plus of 1. Then why this minus is omitted on there? The reason is that question, again I just repeat that question is given the binary BCH code. For the binary case, their minus 1 cannot be happened. So it is replaced as value of 1. Because for the state, if you write down the state as a 0 and then 1 for the binary case, if you subtract 1 from the 1, then it will be come back at the position of 0. If you subtract 1 from 0, that time the result will be come back as a value of 1. Okay, so let take another way by which it will be easy for understand. Let this is the 0 state, this is the 1 state. If you add this 1 plus 1, that time the value will be 1. Again you add this 1, then it will be come back as a value of 0, because 1 and 1 is 0 on there for the single bit or state value position. Now if you subtract, what happened? For the 0, this is 1. When you subtract from 1, you have to subtract. That time the value will be as a form of minus 1. If you subtract 0, that time again the value will become as a plus 1. And for this reason, here we just write down alpha to the power 4 is equal to alpha plus of 1. As the value for the small n is equal to 15, so alpha power is written up to 15. Look that it is written up to 15 on there. So alpha is written as a value of up to 15. So which is starting from the alpha to the power of 1 and end at the alpha to the power of 15. Now you just put the value of alpha 4 position, because you calculate this is alpha to the power of 4 is equal to alpha plus of 1. We just write down this one in this position. We just write down this one position. So alpha 5 can be written as a multiplication of alpha into of alpha to the power of 4. This is for the alpha 5. So for the alpha 5, it can be write down. We just put the alpha 4 value. So it will be alpha into alpha plus of 1. If you multiply these two, then the result will be alpha square plus of 1. That one is written. Sorry, this is alpha. So this will be alpha square plus of alpha. If you consider for the alpha 6, that one can be as a value of alpha into of alpha to the power of 5. So it can be write down alpha into of alpha square plus of alpha. So this value will be alpha cube plus of alpha square. Look that this one is written in this position. If you consider same way for the alpha to the power of 7, so it can be write down alpha into alpha to the power of 6. So this is alpha into of, you just put the value of alpha to the power 6. So this is alpha cube minus of alpha square, sorry, plus of alpha square. So its value will be alpha 4 plus of alpha cube. You know the value for the alpha 4, that is the alpha plus of 1. So alpha plus of 1 plus of alpha cube. So you just write down this one in this position. This way you can ultimately got individual one value up to the alpha to the power of 15. Now lastly we check the value for the alpha to the power of 15 is equal to y as a 1. So alpha to the power of 15 can be write down alpha into of alpha to the power of 14. So this will be alpha into of alpha cube plus of 1, because alpha to the power of 14 is written alpha cube plus of 1. So the product value will be alpha 4 plus of alpha, as we know that alpha to the power 4 is equal to alpha plus of 1, then plus alpha. So here 2 times alpha is used, and alpha plus of alpha, from there if you common the alpha, then the coefficient will be 1 plus of 1. Due to reason of this is a binary type of condition, so there are mod 2 operation you have to do, and 1 plus 1 addition result will be 0. So this two portion will be obsoleted, and the result will be only the 1, and for this written it is written as a 1 on this case. Okay, so these are the primitive element for the condition of BCH code in this case. Now we are interested to consider the conjugacy class. Initially we just consider beta is equal to alpha. Then you just write down the formation this way. This way, that is, initially you have to write down the beta, then beta to the power of q. Q means the what is the mod operation is doing on there. This is the f2 of 4, so q is value is the 2. Okay, and d is the any kind of integer number, so d is written as a form of q to the power of I it can be 1 2 3 whatever. Okay, so initially when you put the beta as a value of alpha, then first value will be the alpha, this is for the beta, then the beta to the power of q. Q is the 2, so this is alpha to the power of 2, that is the alpha square. Then q into of d, so this is q into of d, the integer number on there, so this is alpha square into d square, so this is alpha 4. This will be the alpha square square and then square, so it will be alpha 8. And if you consider this is as a 2 as a form of 3, because we are increasing the value of the I, so this value will be 2 to the power of 3, so this will be 16. So that time the value will be alpha. Why this is alpha? Why not it is written as the alpha to the power of 16? Because here n is the value is 15. Their maximum value for the alpha as a power will be 15. So mod 15 operation you have to do. 16 mod of 15, the result is 1, and for this reason this is written as such. Okay, so if you look, then alpha is repeat again here as a first term. So further there d not required to increase, that means this portion is not required. So conjugacy class will be included by this element. One is the alpha, second one is the alpha square, alpha to the power 4, alpha to the power of 8. This is written within this function. So this is the first conjugacy class. Now in this class the alpha cube is not present, so you have to consider another one conjugacy class. The same way, now the beta is replaced as a value of alpha to the power of q, and the another thing will be, or for the next step will be the same as the previous one. So this is beta is now alpha cube, then beta to the power of q. Q is here the 2, so this is beta to the power q is equal to alpha cube square. This will be the alpha 6, then alpha cube 2 2, d is used on here, so this is alpha 12, then it will be alpha 12, t4 will become, again here this is 24 is greater than the value of the 15, so you have to do the mod operation of 15, so the result will be the alpha 9, to the power of 9. And if you consider d as the value of the now 4, that time the value will become 48. So this is alpha to the power of q. So it is repeat the value of the first one. So not required to do the next step. So here this kind of case, the conjugacy class generate alpha to the power of q, alpha to the power of 6, alpha to the power 12, and alpha to the power of 9 by using this primitive element. So from the first conjugacy class and from the second conjugacy class, if we compare with this between these two, check that here alpha to the power of 7 is not present from this. Here alpha is present, alpha 2, alpha 3, alpha 4, sorry, alpha 5 also not present. So next beta value you have to write down as a alpha to the power of 5. So you have to do this process until you confirm that each and every element from starting to alpha to up to alpha to the power of 15, these elements are not included in the conjugacy class. On that time, you have to do the same process. So you just apply the alpha to the power of 5 and you do the same process. Initially, this will be the beta value, then beta to the power of q, then beta to the power of qd, then it will be increased as such. So ultimately, in this case, the conjugacy class elements will be alpha to the power of 5 and 10. Then you again you have to check by this 3 conjugacy class, and then you look that alpha to the power 7 was missing. So beta now considered as a value of alpha to the power 7, and this case the conjugacy class will be created by using this element. Now each and every elements are present in this case. Okay, so lastly we got the conjugacy classes, and there as only the single one element 0 class, this is another one class only single one, this is already you done, this is alpha, alpha squared, alpha 4, alpha 8. The fourth class will be alpha cube, alpha 6, alpha to the power of 12, alpha to the power of 9. Fifth class will be as a alpha to the power of 5 and alpha to the power of 10, and the sixth class will be alpha to the power of 7, alpha to the power of 14, alpha to the power of 13, and alpha to the power of 11. Now you have to check the minimal polynomial from the individual class. For the first class, the element is 0. So polynomial will be written as a form of x minus of 0, that is only x. If you consider for the second one, that time their element is as a 1. This is written as such. So here it will be written as a x minus of 1, and that one should be equal to x plus of 1 because this is the binary case. Now for the M2, here the elements are alpha, alpha square, alpha 4, and alpha 8. So M2 will be written as x minus alpha, x minus alpha square, this one. You just multiply the general way as you know. So if you multiply these two, and then you have to addition process, and you have to remember that you have to do the mod 2 operation. If there 1 plus of 1 is occur, that time the addition result will be 0. On that case, that particular element will be obsolete on there. If the 3 times 1 is present, that time the value will be the single 1. So you should concentrate on that. So we just go to the last line, so it will be easy for understand also. So in this case, for the first one, this is alpha x to the power of 4, then alpha plus of 1. So this is alpha plus of alpha. So it will be obsolete each other. So only x will be present. So this is written as such. Now in this case, for the last line, same thing is applied for the previous line also. So in this case, alpha square and alpha square, they are used 2 times. So this will be obsolete. Alpha cube and the alpha cube also used 2 times, so this is also obsolete. Alpha plus of alpha, this is also 2 times, so this will be 1 plus of 1 equal to 0, obsolete. So this is single 1 is present, so this is written in this one. in this position. So alpha 4 plus of alpha x, sorry, x to the power 4 plus of x plus of 1 is a primitive polynomial for this case. By using the second one, that is the M3x, you just choose the conjugacy class elements. In this case, the conjugacy class elements are alpha cube, alpha 6, alpha 12, and alpha 9. You just do this one and then ultimately got the value of this, and the polynomial will become as a form of x to the power of 6 x cube x square plus of x plus of 1. Now this one is little bit small portion is used for the calculation, so you just consider for the M4. So if you multiply these two, why this is multiply these two? Because the elements are alpha 5 and alpha to the power of 10. So this is x minus of alpha to the power of 5, x minus of alpha to the power of 10. So if you multiply, the result will be this one. Okay. So alpha 5, this value already you calculate from the tabular one, where you just write down 0, then you just write down alpha, alpha square, alpha cube, alpha 4 is equal to alpha plus of 1. The what was the table you just done on there? So from that particular table, you just put the value of alpha to the power of 5 and alpha to the power of 10. From the table you can check the alpha 5 is given as the alpha square plus of alpha, and for the alpha to the power of 10 it is given as the alpha square plus of alpha plus of 1. That two value you just put as a replacement of this alpha 5 and alpha to the power of 10. So here ultimately do the same binary operation. If 2 times is used, then it will be obsolete. So here alpha and alpha both used for the 2 time, so it will be obsolete the alpha, and this is alpha square, again alpha square, so this is 2 time alpha square, so this one also obsolete. So only present will be the 1, so 1 into x will be x on there, and lastly the 1 is present in this case. So for the M4, the minimal polynomial will be written as x square plus of x plus of 1. So this is the primitive elements also. Same way for the M5, you initially consider conjugacy class element, then product between them, and ultimately you have to do the multiplication process by considering the mod 15 operation and also the mod 2 addition on there. So in this case, the element will become this one. Okay. Now we concentrate how you can got it the gx, that is the generator polynomial for this one. Okay. So you already know about individual class, the what are the value on there. This one 0 is as a value of x as you calculated minimal polynomial. 1 is 1 plus of x. For this one class, it is defined polynomial, and individually you just calculate this one value as a separated way. Okay. So for the gx, that time the coefficient for the 5 primitive polynomial will be written as such, because this will be as is coefficient like this one 2t minus of 1. T is given for this question, t is given 2. So this is 2 into 2 is 4 minus of 1. So that means 3. 3 will be the coefficient value in here. Okay, maximum. And the t, due to the reason of t is equal to 2, so t can be write down as a 1 or as a 2, this two value. If you put the value t as a 1, that time this 2t plus of 1, sorry, minus of 1, this one as a value of 2 minus of 1 when you are putting t as a 1. So this will be 2 minus of 1, that is 1. So this one is used as a suffix phi of 1x, and when t is equal to 2, that time it will be phi 3x. Okay. So these two elements you have to check and you have to multiply, then you can got the value for the gx. So phi of 1 phi 3x, how can you got this one? You already know this one, the table, and for the minimal polynomial you just write down as a phi 1x for the alpha and phi 4 is for the alpha 4, in such way up to alpha to the power of 15. This is written as the coefficient alpha to the power of 15. Now check that here, here this is alpha square, alpha 4 and the alpha 8. It is the same minimal polynomial, that is the m2x. Alpha square, alpha 4 and alpha 8. So that position you just write down m2. So m2 will be write down as a position for the alpha. So this is m2 is written in this position for the alpha. For the alpha square also, this is m2x. For the alpha 4, this is also will be the m2x. So phi 4 will be the m2x. For phi 2 also m2x. For phi 1 is also m2x. Okay. So this one you have to consider from the previous one portion, that this group from this individual position the value will be the m2. For this individual position the value will be m3x in such a way. Okay, we have to record phi 1 and phi 3. Okay, so phi 1 value is ultimately got what? Phi 1 is the m2, phi 1 is the m2, and phi 3 is the m3. So you have to multiply m3 and m2. M3 is which one? M3 is defined this one value, and M2 is defined this one value. So these two you have to multiply to get the generator polynomial. So look that these two are multiplied. Look that these two, for the M2 is put the value 1 plus of x plus of x4, the minimal polynomial. For the M3 it is written as such. If you multiply and then solve it, ultimately lastly equation will become as such, that is 1 plus of x is 4 x is to the power of 6 x to the power of 7 plus of x to the power of 8. So this is the generator polynomial for this kind of code. Now the question is given that if it is, so you can check that this kind of consideration can be made on there. So in this BCH code, what will be the d-mean? D-mean should be from the specification. Already we know that for the BCH code d-mean should be as a 2t plus of 1 less than the value of 2t plus, sorry, greater than the value of 2t plus of 1. So this will be t is equal to 2 in this case. So this is 2 into 2 plus of 1, that means 5. So for this kind of BCH code, binary BCH code, that d mean should be greater than equal to 5, and n minus of k redundancy bit value will be should be less than equal to of mt. M is this calculated by you at the initial moment, that was the 4, and t is the 2, so this will be the 8 on there. And from the conclusion we can make that we can imply 15,7 binary BCH code, and for this binary BCH code the generator matrix should be is equal to this one, that is the 1 plus of x is 4 x is 6 x is 7 and x 8. So if you know the value of the g, that time code word can be available, because by using the formula, that is the c code word matrix is equal to, this is d the data or message matrix, and this is the g by using the generator matrix. So from the generator polynomial you can got the generator matrix, and if you multiply with the message bit, then code word can also be easily available for you for this binary BCH code, and that is the 15,7 binary code. So I think each and everyone can able to understand what is the way by which you have to generate the generator matrix for this kind of question, and hope all of you stay safe, and we meet again for the next day, next class with new topic. Till I have to say have a good day and bye.